Hello, and welcome to today's webinar, How Does a Recycling Plant Achieve a 4-Month Payback on AI and Robotics Solving Labor and Recovery Challenges? I'm Deanne Toto, Editorial Director of the Recycling Today Media Group, which publishes Recycling Today, Waste Today, and Construction and Demolition Recycling magazines. I'll be moderating today's webinar. We'll be hearing from Apurba Pradhan and Samir Kamat of EverestLabs, who will explore the potential labor and recovery impact of applying artificial intelligence and robotics in a material recovery facility. They plan to share real-world case studies across plants in North America to assess the true impact of data and robotics on different sorting lines, evaluating the cost versus the benefits. Many of you likely have heard that applying AI and robotics to MRF can help address labor challenges, provide consistency in sorting, increase recovery, and give operators improved visibility into their sorting operations. In this webinar, Apurba and Samir will aim to provide you with the knowledge to critically weigh an investment in AI and robotics against tangible operational gains. First, we'll be hearing from Apurba Pradhan, who heads product and product marketing at EverestLabs. He works with recycling companies to identify their needs and with the EverestLabs team to build solutions to meet them. Apurba has more than 20 years of experience building software and solutions for infrastructure in industrial markets. We will also hear from Samir Kamat, who is the lead solutions engineer with EverestLabs, He was part of the original engineering team that developed the foundational AI models and robotics the company uses. He has since transitioned into helping recycling companies identify their needs and assess solutions for data and automation at their facilities. Samir is a mechanical engineer by training and has a master's degree from Carnegie Mellon. Before I hand off to Apurba, I'd like to remind you that we will be recording this webinar, and that will be sent out to registered attendees within a week's time. Also, we will take questions after Samir and Apurba have presented, but you can submit those at any time during the webinar by hitting the Q&A button, not the chat button, at the bottom of your screen and typing in your question. Again, to submit a question, click on the Q&A button and not the chat button, please. Now, I'd like to hand it over to Apurba.
Thanks, Deanne. Thanks for Recycling Today team for hosting this webinar. What Samir and I wanted to talk about today was just really get practical on AI and robotics for material recovery facilities, reclaimers, recycling plants in general. I think AI and robotics have been in the scene for recycling probably for about 4 or 5 years now. Probably since before COVID, and a lot of people in recycling have heard about it, may have even some practical experience with it, but we realize a lot of people haven't. And so what we wanted to do was we wanted to spend some time giving firsthand, all of the firsthand information and knowledge that we've gained in the last 2 years of deploying AI and robotics in material recovery facilities and reclaimers. We wanted to give that in as a practical way as possible to people attending this webinar. So it'll really be just kind of an overview of the benefits of AI and robotics brings to recycling facilities, both from a recovery standpoint, but also really focusing on the economical side of things. I think there's a mental hurdle that people have to go through to understand what AI and robotics brings to the table. We want to sort of make that hurdle lower for people with this webinar. So we're going to be talking about some real world experiences. We're going to be going through where robotics fit, where it doesn't fit, what the costs are, what the true costs of running AI and robotics are versus manually sorting, and lay it all out for you so that you have a much clearer picture of what the state of AI and robotics are today. So with that, I'll kick this webinar off. I want to talk a little bit about the basics. So all AI and robotic systems in sorting facilities, there's 3 basic steps that we're one of a few handful of companies that are deploying AI and robotics today. And all of the systems that are available to you have sort of 3 basic components to it. The first is a vision system or some way of seeing what's on your material belt. So this is a video on the left-hand side. Ours is a vision-based system. Some companies utilize hyperspectral or some other detection techniques. We use a camera system. We use a 3D camera system. There's two cameras in there creating a stereoscopic image of what's going on under it. This is a typical mixed recycling stream that's gone through pre-sort and maybe gone through one layer of sorting, taking out cardboards, and this is sort of the container line that's going through it. This camera is looking at all of the objects underneath it and providing that data to an AI platform, usually a edge compute system that can run AI models on that video stream. So I'll pause that one, and I'll show you what the AI sees. So the AI, this is where we apply AI to the video stream, and what you see here is green boxes that's identifying the materials. The AI can identify, all types of plastics, different types of metals, different types of fiber, paper and cardboard included. And what you see here is it's a fairly tough problem to solve, and that's because of all of the variability in the materials that the camera sees, as well as sort of the condition of the materials. You can see materials are very, overlapping each other, pretty dense flow of material, and the AI has to sort of separate those into individual objects, run it through a model, and identify what that object is. And we don't need a perfectly clean stream of material. We can have overlaps. We can have a slight, sort of chaotic environment like this. The AI have gotten to a point where it's good enough to detect objects at very, very high accuracy in a stream like this. And whereas I think in the beginning stages of when people were deploying AI systems, the amount of data that the AI models were trained on wasn't as robust. So maybe in the beginning, the AI identification challenges were harder to solve. But over time, we've been able to solve that problem by applying more and more data into the AI models. Finally, then that AI model, once it determines what those objects are and sort of the trajectory of that objects under the belt, it programs or provides the input to the robotic so that you can program the robotic to do the sorting. And at this point, we've probably about second generation of robotics that are deployed in recycling facilities. The robotics in the early days were less accurate, slower, and harder to deploy and costly to deploy. We've sort of refined that over time. What you're seeing here is our current generation of robotics. These are 6-axis robots that mount to a side of a conveyor belt, and you can program it to do various things, right? At the highest level, you're either doing a positive or a negative sort. So either taking out contaminants, which is a negative sort, or picking good objects from the material sort, which is a positive sort. And through that, you're figuring out where you want to drop those objects, what priority do you want to pick objects on a line. So the robotics are really then taking the sorting and automating that sorting, and we'll kind of go through what types of tasks the robotics are now really, really good at, and what are some of the emerging tasks. So I wanted to lay out sort of, from our experience, practically, what are some of the common tasks that the robotic sorting are doing today, and what are some emerging tasks that we're seeing that the robots are being asked to do? The common tasks are around QC of plastics, metals, and fibers after they've gone through one level of sorting, basically cleaning up the material stream going into balers. Robotics are also quite good at now installing into last chance lines and residue lines and recovering any additional material that was either missorted or not sorted in the MRF. Robotics can go in front of balers and clean up the materials, going one more level of cleanup before it goes into the bale to meet some of the purity requirements. We also deploy robotics in reclaimers. These are companies that are buying feedstock, either containers or bottles, packaging, that needs to be sorted. So they do a level of sorting before it goes into their process. Robotics can go there and clean that up. So those are sort of everyday tasks that we're excelling at, have very good experience with. Some of the emerging tasks on the right-hand side are areas where robotics are starting to be deployed and starting to get good at. Removing film and flexible plastics is one of them. Ejecting batteries out of material recovery facility streams where it could be cause fires. Those are another tasks. Removing explosives. We're also seeing a need for recovering brand specific packaging. So being able to identify packaging, not just by material type, by brand and packaging type, and being able to recover those. And then also in construction and demolition facilities where we're removing things like wood, concrete, blocks, electronics, metals from construction demolition facilities. So these are all sort of suitable tasks. Some are, sort of commonplace. We're doing it every day. And then some are sort of more emerging tasks that we're looking at. Just a plug here for EverestLabs. We've been in the business since 2018, and we've been deploying these systems for the last 2.5 years in production. And some of the things that we really excel are listed here on this slide. As I mentioned, we have a very, very flexible robotic cell. And what that means is these are small form factor, high-speed sortation robotic arms that installs pretty much anywhere in the facility with very, very little costs to retrofit a line. You see here the picture on the left-hand side. We can install on incline belts. We can even install over belts if there isn't a platform to install the robotics on. The picture here on the bottom side shows it can go in a very small linear space constrained system. So a lot of times QC lines, there's very little space to install large robotic systems on. We can install in a footprint of about 2 foot by 2 foot on a pedestal on the ground to be able to provide sortation right after optical sorters. So extremely simple. Flexible robotic cells. They're also very configurable, right? If there's a task where there's a lot of objects that need to be sorted and one robotic system is not enough to do it, you can install two across the belt from each other. You can even install them serially one after another. So you can cover a lot of ground with these types of robotic cells. The second is we focus on operating these robotics remotely on behalf of the recycling facility. So we understand that the reason companies are deploying these robotic cells is so that they can reduce their staff and labor requirements, and there isn't necessarily a person on staff in recycling facilities to be able to man these robots. We've instrumented these systems with cameras and sensing so that we can run these robotics remotely through our robotics operations center. So what you're looking at here in the middle is IP camera feed of all the robotic systems that were deployed. Our operators are looking at this and making a determination on whether the robot needs maintenance or whether there are certain conditions that require us to do some maintenance or troubleshooting. We're also getting that same information through sensors that are outfitted both in the edge compute modules as well as in the robot. We're detecting successful picks. We're detecting the health of the compute system. We're detecting what maintenance level whether it's the compressed air or the end of arm tool, and what the maintenance levels are for those, and we're making real-time adjustments so that we can deliver results that the robots were originally purchased to do. And the third point here is we're really results focused. So we drive all of our metrics around successful picks. We focus on making sure that our robotics delivers at least 80% or higher successful picks, which means 8 out of 10 picks that it went for, it was successful. We track that on on a daily basis, an hourly basis, and we make adjustments if those numbers are coming down. If there's maintenance maintenance needs that's causing the results to go down, we inform the operators on the ground what to do. So really, just we're tracking the results and optimizing it, and that's because a lot of times some of the complaints about robotic systems is that it works great when it's initially installed, but over time it loses performance, and we wanted to make sure that wasn't happening. And this data is available to you up to the minute through a cloud platform as well if you're a robotics operator, and you can be tracking how your systems are doing at any given time. With that, I'll hand it over to Samir to talk about real world experience with robotics, what the true costs of robotics are, and what the true costs of manual sorting are, so that we can do a comparison later on.
Thanks, Dian. Thanks, Apurba. So let's look at how our robots perform in the real world. So this is a graph that compares the performance of a human sorter with an Everest robot. As you can see, the y-axis has picks per minute and the x-axis has number of hours in the day. So the orange line here depicts the performance of a human sorter. At the beginning of the shift, the sorter is super enthusiastic. Here, the sorter is fresh. So we've seen the sorter start with the day with anywhere between 60 to 80 picks per minute. But as the day progresses, the efficiency of the start of the sorter starts to reduce. And that happens over the course of an 8-hour period. However, with our robotic system, we have seen that our robots are up and running and can sort up to 65 picks per minute. And it's always available. So the sorting of the robot depends on the availability of the material, while the performance of the robots are constant, while the manual sorters, their performance continues to go down, or the productivity continues to go down as the day progresses. So on average, our robot is as good or even better than a manual sorting on container and residue lines. Just doing a quick analysis from this chart, we've seen that our total items recovered by our robots could be somewhere in the vicinity of 20,000 objects in an 8-hour period. Similarly, items recovered manually are nearly half of it, or about 11,000. Next, Apurba. Thanks. So one question, so one frequent question we get from our prospects is, can our robots perform on any sorting line? Apurba, can we look at the other video? Thanks. So if you look at the video on the right, you see that this is a typical OCC QC line. There are large pieces of cardboard on the line, and the sorters are looking for anything that's not cardboard, and they're trying to sort through residue and containers. Now, a line like this one is something challenging for our robots to go on today, right? Because our camera systems can only see material that's on the top, and it cannot see what is hidden under a large piece of cardboard. And as you can see, the sorters here are working really hard and really trying to clean this material up. However, having said that, our robots are ideal to sort through material on like QC, container, last chance line, as well as baler lines. And you can see the robot working here on a color HD QC line, where it's doing up to 60 picks per minute and has successfully recovered 52 items out of the 60 attempts. And that marks our robot efficiency at 85%. So as long as the material is well spread out and is visible to the naked eye, we can guarantee that the robot can go for the material, can detect it, it can identify it, detect it, target it, and successfully recover it more than 80% of the time. Next. Okay, so let's talk a little bit more on what are the factors that impact manual sorting cost. For simplicity, we have subdivided this into 4 different categories. The first is the labor and overhead. So a salary of a sorter could be anywhere between $40,000 a year to $100,000 a year. in the US, depending on location and function. And the overheads could be anywhere between 20 to 40% for benefits, social security, insurance, and you can add another 5 to 10% for workforce injury or illness that could impact the business. Similarly, the employee turnover is anywhere between 30 to has like a 30 to 40% turnover rate, and each employee costs approximately $5,000 to hire. And sometimes temp agencies can charge 25 to 50% more. The third one is number of shifts, and this is an extremely important factor in how the manual sorting is calculated, because a typical recycling facility needs 2 sorters in a 2-shift plant, needs 3 sorters in like a 24/7 or 24/5 plant, but just one robot is enough to sort through the line throughout the day, right? So if you have a facility that's running 24/7, and if you have a sorting line, then you need to keep changing. You need 3 different sorters to really position in that in the sorting area. But if you were to install our robotic system, then this robot would really replace 3 sorters, right? And again, each shift requires a site manager, supervisor. So there are some hidden costs that in the calculation of manual sorting that is not very evident. And at the end, it's the fourth one is consistency. It's difficult to keep quality of sorting high. Pick rates can vary 5 times over the course of a shift. And what we have seen is with sorters not showing up for work, that can result in MRFs running lower volume of material that really impacts the business and increases the operational costs. So it's we are not surprised to say that, or see that, sometimes it could cost businesses nearly twice as much, as much as a just a regular salary or for each sorter. Yeah. And now let's talk a little bit about, let's compare these costs with what it costs to put a robotic arm on, right? And a lot of times we are asked is, okay, what does the installation mean to you? Or, how are there any installation costs? So our robotic systems, as Apurba mentioned, are easy to install. They occupy a small footprint, and they can even go in places where the egress may not be as high. So our robotic systems require little to no retrofit and takes about a day to set up. As far as the product costs are concerned, the package includes the hardware cost and the software fees needed to capture video, run AI models, robotics, to run any customized dashboards, data reports, you name it, right? We don't nickel and dime you for any of these additional features, or if you want to change any pick priorities, or you want to make any adjustments to the robots, we are there for you, and we want to make sure that we meet and exceed your expectations. The third one is operational oversight. So as part of our robot as a service model, we monitor the robots 24/7 for you, right? We make sure we have a robot operations center, as Apurba mentioned earlier, that makes sure that we keep the robots running and make sure that it's always getting the housekeeping and the maintenance it requires, and it's always running at its peak performance. And then this is a common one. What about suction cups? What about consumables, right? And as part of, again, as the robot as a service plan, we provide all consumables, repairs, replacements, all that is included in the package. So there is no additional cost. It's like kind of a one-time deal where we once you've signed up for a robot, then it's kind of our responsibility to make sure that the robots are up and running, provided you have power and internet, really. And that's about it. Next. So the image on the left is a photo from one of our install sites. As you can see, the install is pretty compact. We have 2 vision systems and 2 robotic systems on a container line here. and the pedestals are just really bolted to the floor, and the robot sits right on top of the pedestal. So it takes about a day to set up, really. And housekeeping is as simple as using a bottle cleaning brush to clean our end of arm tool, and replacing the suction cup is easy. It's just a quick pop in, pop off kind of a design. So all we need is, once we have set up, and you can see how easy it is to set up from this image on the left here. Once we have set up, once the robots are ready to go, all we ask is you clean the end of arm tool once a day, and you replace the suction cup once a day. Again, we provide the bottle cleaning brush, we provide the suction cups to you. All we ask is 30 seconds of your time to make sure that the robot end effectors are clean, and really they're ready to go to get best recovery. Next.
Thanks, Samir. And hopefully the last few slides that Samir shared helps you kind of picture what a robotic install may look like. And because if you don't have direct experience with running these systems, it's hard to sort of imagine what it would take to purchase, to install, to run these systems. So hopefully the last few set of slides made that a little bit more clear for you. What I'll go into next is the economics of running robotics, and I'll take a few examples here, real world examples, and walk through it with you so that it's very clear. And these economics are based off of our robot as a service model, where, as Samir mentioned, it's an all-inclusive service that includes the hardware, the software, the data access, as well as the maintenance and the replacement parts as well that's needed to run these robots efficiently. So this comparison here is for a 2-shift plant. This is a robot that's doing quality control task. So essentially picking out contaminants from a line. It's a single robot replacing a manual sorter on a 2-shift plant here. So the average sorter salary here in this facility is $25 per hour, which is roughly around $50,000 per year for that sorter. Now, as Samir mentioned, this is one sorting position. So if you're manually sorting here, you need 2 sorters in a course of 24 hours to man this sorting position. And I've assumed here a 30% burden rate. This is the amount that companies are responsible for outside of the hourly rate that you're paying the sorter. This covers insurance, this covers benefits, this covers all of the Social Security type benefits that needs to get paid out. What we don't factor here is the retention cost of a sorter. We know that these jobs are very hard to staff and keep staffed, and there's a cost associated with hiring new people, and that cost we haven't factored in, but that would generally tend to increase this burden rate as well. This is a 5-day-a-week plant, so you're running 260 days in a year. The install cost, an average install cost for one robot for us is roughly about $15,000. This is split between the cost that you'd pay EverestLabs to supervise the installation, as well as the contractor to come in and mechanically install the pedestal, mechanically install the vision system, as well as running electrical to the systems, and then running compressed air to the systems as well. Typically, if you don't have compressed air already in your facility, you can have that installed, and a lot of companies will now install that as a subscription basis. Well, they'll charge you a monthly cost for having a compressor and compressed air in your system, and those costs are fairly minimal. It's a couple of $100 per month, something like that. This economics is calculated over a subscription term of 3 years. As I mentioned, these are sort of long-term contracts that recycling facilities sign with us, and it's typically, you know, greater than a year and less than 5 years, and 3 years is a standard subscription term for us. And what you're looking at here is a labor saving. So you in this period, in the 3-year period, year one, you're saving about you know, every year you're saving about 135K, because this is 2 sorters that you have to pay with this robotic systems. In this case, you're not increasing recovery. We basically assume that the robotic system, in terms of picks, is doing the same as the person. So in terms of, you know, additional recovery or cleaning up the bale better, we're not factoring those economic benefits of that. We're just assuming that it's a 1-for-1 replacement. So the total and for a system like this, the total robotic cost over a course of 3 years. This includes all the maintenance, all the product cost, the software cost, is $270K. So here you're net profiting per robot about $135,000 in a course of 3 years. That's a payback of 4 months on a system like this. So with, you know, after 4 months of running this robot, now you're net positive in terms of the economic value that this robot delivers. Typically, there's multiple QC lines in a material recovery facility, at least 5 different QC lines. So if you look, if each robotic system is bringing you a profit of about 135K while doing the job that you needed to on the QC line, 4 or 5 robots will net you about a savings of about $500,000, which is quite significant for a 2-shift plant. Next, I'll give a little bit of a different example. This is a single shift plant. This one's actually running 10 hours a day, 8 hours sorting and 2 hours maintenance. And in this line, it's a residue line that the robot is going into. So there was that residue line was previously unstaffed. There was a lot of materials coming in, containers that were being landfilled, and this operator wanted to take advantage of the robotics to recover every last bit of commodity that was available. And so this is a slightly different use case. You see here, this is a 400-ton plant. You know, where this robot was programmed to pick HDPE color. You can program the robotics to prioritize what it picks. It can pick when it's available HDPE, and then when it's not available, you can program it to pick PET. So there's a lot of things you can do, but this economic calculation is based on picking HDPE color off of this line. This is one robot. There were no people on this line. And this facility, as I mentioned, is running a 1-shift plant, had about 30% residue in the stream, and the landfill cost for this operator is about $50 a ton. Because as you're taking out material from the residue line, you're also saving on the landfilling cost of that material as well. So we've assumed a $50 per ton fee here. It's not a labor savings discussion, because there really wasn't somebody here sorting before. This is really an increased recovery plus landfill savings discussion. You can see, even at a modest facility as this one, you're saving about $340, or you're recovering additionally about $340,000 of material in a 3-year period. In the same period, the robot costs about $210,000 in this facility, which is a net profit of, again, $131,000 per the 3-year subscription term. Again, the robot here pays for itself in a course of 4 months. And if you're doing sort of you know, economic ROI type calculations, typically, you know, you look at projects that are, you know, have a payback of less than 2 years. Those are decent projects. If you've got a project where the payback is 12 years, those are great 12 months. That's a great project, because you're basically making your money back in 12 months. If you're looking at projects that deliver you payback in 3-4 months, those are fantastic projects. And so these economics are real economics that AI and robotic systems are delivering today. I'll give you a slightly different example as well, since we have a little bit of time here. This is not an economic calculation of what the robot has done, but this is a planning tool that we've helped recycling facilities with, in terms of planning for different scenarios that they're anticipating. And this is really sort of making a case for the AI system that can help drive decisions. So here, the recovery facility is trying to decide between how to staff their last chance line. So they've got 5 workers, 4 different commodities that they need to pick, and they're coming in at various rates. So if we know the commodity pricing and we know the material distribution from the vision system upstream that is telling you how much of each commodity is coming, we know we can then work out, okay, how much picks per minute does a sorter or a robotic system need to do, and therefore be able to strategize on how many sorters or how many robots you can place. Here, in this case, it's 50 picks per minute. If you want to sustain that over a course of 2 shifts, 16 hours, that's usually you need 2 people to do that. With the robotic systems, we can do that with 1 person. You can see here that the net profit of running manning that PET line is actually negative, but because you have recovery rates and contracts that you're compliant, you're beholden to, you need to staff those lines. So in this line, you're making a negative profit, but on the HTP and UBC lines, you're making a positive profit, and this is sort of, this column here shows you the profit that you'd be making with a manual sorter. This column shows you what profit you'd be making with robotics. Now, that's valuable in itself. I think the additional value that AI and data can provide is what would you do if things changed? We know that in different months, a different amount of UBCs come in, so you kind of have to reorganize your sorting strategy here. If you factor in months where your can recovery is, or you've got a lot of aluminum cans in your recycling stream, you got to shift some workers around, or you can shift the priority of the robotic system, where before you had robot dedicating half its time to picking UBCs, you can now dedicate the robot for all of its time to pick these UBCs. You still have 5 sorters or 3 robotic systems, and you can see, okay, for the future scenario where I might have more UBC, I can actually net out profitability in a different way. And these are all configurable. Once the vision system and the AI is running, this data is available to you in a very granular fashion, so you can make strategic decisions around how you run your operations. And with that, I'm going to turn it back over to Samir just to talk holistically about AI and robotics and MRFs. Samir, you might be on mute.
Thanks, Apurba. So let's visualize the flow of material in the MRF. It's everything starts from the tipping floor, where the material comes to the first pre-sort station, right? And we have pre-sort stations in the MRF. We recommend adding vision systems at these pre-sort stations, so you can monitor what is actually coming into the plant, right? And you can, get this material composition of everything that is coming in and that needs to be sorted. We are potentially looking at highlighting some materials such as detecting batteries, fire extinguishers, propane tanks, anything that shouldn't be there, and alerting the team on site to remove that material before it goes through further sorting. So we can start with vision systems on the pre-sort line, and as I discussed before, we are working on getting robots to be there, but they are not there yet as today. The material then goes through different kinds of equipment, right? It goes through glass separators, it goes through magnets, optical sorters, eddy currents, and these are all must-have equipment in any MRFs. What follows these equipment are all the QC lines. So typically any MRF would have 4 kinds of plastic QC lines, and then a few other fiber QC, as well as an aluminum QC line. And at all these QC stations, we have seen that it is just an ideal position to deploy our robots. And depending on the number of shifts the plant is running, you could be replacing anywhere between 5 people on QC lines in a 1-shift plant to 15 people in a 24/7 plant, right? So that's big cost savings for the business as well. Finally, all the material that is sorted at these QC stations goes into the bunkers or the silos, and then all this material goes to the baler. We can look at adding a vision system and a robot at the baler at the baler line to remove contaminants before the material gets baled, right? And what the vision system really does is it provides you with a bale quality report and tells you exactly how pure your bale is. So you could imagine in a world where you could take this report, go to the buyer and say, hey, my material is 99% pure, right? And you could get premium price for your material, which is kind of, not possible today. And that's a whole different process of negotiating with buyers, trying to figure out, who the best buyer is, and going from there without having a glimpse or any real proof of how clean your material is. And there's sometimes instances when the buyer might come back and say, "Hey, this material is not as pure," and then your guys, your operations people would have to then spend more time figuring out why that is the case, right? So all that is time consuming. It's really not efficient, and again, you just want the best buck for your material. Similarly, all the material that is not processed, it goes to the last chance or the residue line. And we again highly recommend that we start with at least putting a vision system on the last chance line so you know the efficiency of how well your MRF is running. We have seen some heavy leakages and a lot of MRFs where something upstream might break, right? So that there could be some inefficiencies in sorting upstream, and that could all result in materials such as like aluminum cans and PET on the last chance line. And again, we can equip that with a robot to divert all that material and send that to the commodity bunker before it goes to the landfill. So we can really divert all this material from going to landfill. If you are in like a state like California that has CRV, every PET bottle is worth 5 cents. So really there is a lot of value in diverting material from the last chance line. Also, the other thing is once you have vision systems across different points in the MRF, you can really track the health of your equipment before and after it goes through that particular equipment, right? So, like for instance, between first pre-sort and second pre-sort, depending on the size of material you're seeing, so we can even provide you with size distribution of say cardboard or fiber. In case of that, how efficiently your screens are running, or the screen is broken. Sometimes it takes several weeks or months to figure this out. So we can add again, the other value of adding the vision systems before and after each kind of equipment is to really understand how efficiently that particular equipment is functioning, working, and really, kind of perform predictive maintenance even before the equipment goes down. So there's huge value in putting vision systems across different sites in the plant. And again, as we discussed, there's great value in replacing or putting robots on all these QC lines, container lines, as well as last chance lines to divert and recover all this material. And we are happy to support. We are happy to work with you in determining where these points could be. So if you could reach out and let us know, we're happy to do a site survey with you and work with your operations team on where these vision systems and robots need to be installed in your facility and what our recommendations would be. Apurba, I think you're on mute.
Oh, sorry. Thank you, Samir. Just wrapping up here with some of the key takeaways. As I mentioned, the industrial robotics in material recovery facilities are at this point in its second generation. It's able to perform many tasks well, at least as good as manual sorting. And with flexible robot cell designs and this robot as a service model, the payback on the investments can be very short. So hopefully that was clear through this webinar. And we believe that AI and robotics will become a common tool for MRFs to improve recovery as a key part of upgrading MRFs for lowering costs, for increasing recovery rates, to keep up with a lot of the requirements that EPR laws and other recycling policies are placing on MRFs. AI and robotics will become a key tool. And we're here to support. And with that, I'll turn it over for any questions.
Thank you. We've had quite a few questions come in. Just a reminder that if you've got any questions, please submit them through the Q&A function. And also, we will be sharing a recording of this webinar via an email within a week's time. So if anybody wants to go back and review it, you'll have the opportunity, or share it with other people on your team. You'll be able to do that as well. I know that Samir did talk about where some of the technology is best applied in a material recovery facility, but we also had somebody asking about whether the EverestLabs robotics and AI can be used in a C&D material recovery facility. Gentlemen, do you have any experience in that area, or what? Just could you speak more broadly about why or why not the technology could be applied there?
Yeah, I can tackle that one. We have had experience deploying robotics in C&D facilities. That's not where we focus on as a company. We focus on material recovery facilities and reclaimers, basically packaging and household waste. There are opportunities in C&D facilities with very similar technology, just applied to a different set of materials. I think the robotic arms need to change a little bit because the material that you're picking on C&D facilities are different. We don't today commercially sell into C&D facilities. While we've done pilots and we've worked with a couple of C&D companies, we're not in that space. Just for our business is not focused on that space. But if you have a need, we're happy to talk through it with you, see whether we can provide a solution. If not, there are other companies in this space that focus on C&D facilities as well, and I encourage you to check those companies out as well.
Thank you. Then we did have a question regarding the remote monitoring that your team is doing. Is your team centrally located, and where? And then what would the responsibilities of that remote monitoring team be in terms of maintenance versus what responsibilities fall to the actual MRF in terms of maintenance?
That's a fantastic question. So we've got two teams because we're monitoring these systems, throughout the course of the operation. We've got two teams. One team is here in the US, and another team is in India. And what they're doing is they're looking at both video feeds as well as the diagnostics that are coming off of sensors that are in the robotic systems. And they're doing two things. One is monitoring the health, and then the second thing is monitoring performance. On the performance side of things, they can do remote optimizations. So they can change settings and reset robotic systems to get the performance to its peak level. On the maintenance side, they can also do some maintenance remotely, but a lot of the maintenance that's required on an ongoing basis is things that are sort of regular housekeeping type tasks that Samir mentioned. So some of the common ones there are the wear and tear on the suction cup, or the compressed air volume, or calibration of the end of arm tool. Those are very straightforward adjustments that can be done by recycling facilities. And when we notice that those systems need adjustment, we send notifications out to the operations staff for them to take action. So it's a combination of performance and health monitoring, taking actions that you can take remotely, and then if actions need to happen at the field, it's kind of a direct line of communication with the operations team to let them know what needs to happen. And then once that task has been done by the operations team remotely, then we reset the system and start monitoring again. So it's a fairly sophisticated set of tools that we've put in, and we've needed to do that just to build the trust of recycling companies that they don't need to man and staff and worry about these robotic systems. And it's a feature that we've added to be able to build trust with our customers.
Thank you. Could you talk a bit more about the actual installation process and what other costs operators may need to factor in?
Samir, do you want to take that one?
Yeah. So the costs are nearly uh, so as far as the cost for maintenance are concerned, there isn't really any maintenance cost apart from what it takes for a staff to go in and replace that suction cup. It takes about 30 seconds of the time. Outside of that, all suction cups, consumables, any hoses, any fittings, all that is provided by EverestLabs. So that is all included in the price.
I think the costs were more specific on installation costs, if you can address that one.
Okay. For the installation costs, as Apurba mentioned, we do have an installation cost that we send an engineer on site to really help install the robotic system and to calibrate it and make sure that all the sensors are tweaked and the systems are running as it's supposed to. As far as installation is concerned, we ask that if you have a couple of mechanics on site on your team or an installation company you work with, we can partner with them or we can work with them on getting these installed. So the physical installation, we ask that your team do it, and we will support it using our engineering team.
Thank you. Any other questions, Deanne?
Yes, I was wondering then what warranty or guarantee EverestLabs provides for its robotics and AI.
Great. Yeah, that's a great question. As we've touched on in the call, we provide a full service. We call Robot as a Service, and with that service, you have access to all the consumables and repair parts for repair. We also warranty the hardware under that plan as well, and any servicing that's needed for the hardware is all covered under that cost. So it's really a one-stop shop under that umbrella. Everything is covered.
Great. And I know you had experience working with MRFs operated by Sims or Republic. Can you talk a little bit more about those experiences and what the companies were able to realize partnering with you?
Since Samir works with those customers very closely, I'll let Samir address that.
Yeah, thanks, Dan. So we have a bunch of vision systems as well as robotics that have been deployed in Sims balconies or even at Republic plants, right? And it's been a great partnership so far. They have seen our immense value in getting these systems out there, and as we would have liked, they want to work with us more. So there's definitely been a lot of projects we are working on and trying to expand our offerings to them.
Yeah, and we can't get into specifics of what we've done for each of these customers, but like we mentioned earlier, if there's an interest or a need in your facility, we have a team, pre-sales team, a solutions engineering team that goes and does a full evaluation of your facility. They can identify lines, what's best suited for AI and robotics. They can do simulations on that line to see what the performance you can expect is. They can provide you with economic calculations like the ones that I've shown you in terms of what the payback on those investments could be, all the way to the point where we can sort of give you a full report on sort of plant operations before and after AI and robotics. So I encourage you to take advantage of that. That's a free service that we offer. And so if you're interested in sort of what results you can get or others have gotten, we're happy to work with you on that.
Thank you. And we have somebody wondering what robotic brand that you use.
Yeah, it's a good question. So there's a lot of industrial robotics companies that develop robotics for various automation applications, and we've used pretty much robotics from most of those manufacturers. The one that we deploy most commonly are from a company called Fanuc. We buy industrial robotics arms from them. And we outfit them with sensors. We outfit them with software that's needed to do these picks. And then we basically program those systems so that it does the task that's needed to be done in recycling facilities. Like these robotic systems are not designed for recycling facilities. They're designed largely for manufacturing. So out of the box, it wouldn't work. So basically, our team have taken these robotic arms, industrial robotics arms, and really outfitted them for the purpose of recycling and sorting recyclables.
Thank you. We have a number of questions that were more, specific in terms of price. So I'm sure you would be happy to have, one-on-one discussions with those people related to their questions. You can get a little bit more, information on their operations to be able to give them the best information possible. So I believe you'd welcome them to reach out to you by email in order to start those conversations. Is that correct?
For sure. I think my slide is still up. Our email
Yes.
addresses are listed here. So feel free to reach out. And even if you're not in the market for AI and robotics today, but just want to know what you might expect in the future, we're happy to have those conversations.
Great. I'll give you an opportunity to give any parting words that you might want to give, and then we'll wrap it up.
I just appreciate everybody joining the webinar. Hopefully that was instructive in terms of just practically what you can expect, and look forward to communicating with you folks in future events.
Thank you. Then just a reminder, you will receive an email within a week's time with a link to view this webinar again, should you wish to. And like we said, please reach out to Apurba and Samir directly if you have any questions that we were not able to get to here. But thank you, gentlemen. We appreciate your time and your insight, and wishing everybody a great rest of the week.